This is a video to help students with B-90 through B-93, the classwork. It'll help with the homework that was assigned with this accompanying lesson. So in B-90, the classwork, this young student named Mitchell, he came up with a way to write an equation of a line. Remember, equation of a line being y equals mx plus b when we have the slope-intercept form, where m and b are parameters. If he's been given these 2 points, he wants to find the equation of a line using systems. So he took the 2 points and he used them into that equation. Now he doesn't know the m or the b, the slope or the y-intercept, but he plugged in the x and the y values for it. And then looking at that as a system of equations with 2 variables to solve for, he subtracted one equation from the other, and you can find that m equals 4. Then substitute that back into one of the equations, and you get that b equals -5. And since we now have our parameters, we have our m and our b, we can substitute in the 4 and the -5, and we have the equation of the line, which is y equals 4x minus 5. The question was, is this method that Mitchell used by taking the 2 points, plugging them into this equation for the x and the y value, using systems of equations to solve for your slope and your y-intercept, does this work for all lines? But if we look at his method, and it will always be this way in his method, you would always solve for the slope first. So Mitchell's method, since it solves for the slope first, if you had a line that didn't have a slope, you wouldn't be able to use his method. And if we really think about it hard, we realize that vertical lines have no slope. They have an undefined slope. Horizontal lines have a 0 slope, but vertical lines, so Mitchell's method works for any line except for vertical lines. Since that's the case, let's look at it, problem B91, where you're given 2 other points. So again, we're going to use the y equals mx plus b, or the slope-intercept form, and here 2 points. And we plug those 2 points in and write 2 equations. So I'm going to plug the first point in, my x and my y, and the second point, 5, 6, and plug that in. I now have a system of equations, and if I subtract one equation from the other, it's going to eliminate the b, the y-intercept, and I can solve for m. Plug that value for m into one of the equations, and I can solve for b. And from that I can write the equation of the line. In the next part of the in-class exploration, it was, would Mitchell's method work for our knowledge of exponential equations? When we're looking at this format for the exponential equation, y equals a times b to the x. Remember that a and b in this case would be our parameters for an exponential equation. They would be our constants. And so here are 2 points, and just like we did with the linear equation, we just plugged in the value for our y, plugged in our value for our x, and we do that with both points. Now, there's several different methods to use, but in the textbook they said to solve both of these equations for a first. So with the first equation I would divide by b squared, and I'd solve for a. We have to remember then, in this case, b can never be 0, which is important because over here, if we were dividing, and if b could ever be 0, we would be doing something that's not allowed in mathematics. So we know that b cannot be 0, and so it's okay to divide by b squared. The second equation, we're going to divide by b to the 6th. And since they both equal a, then they are equal to each other. And now we're just going to keep solving this. One of the steps, the easiest method would be to cross multiply. And so we'd have 16b to the 6th equals 256b squared. We're going to divide both sides by b squared because we need to have all of our b's on one side. And when we do that, well, the b squareds cancel out. And over here on the left, I've got b to the 6th divided by b squared. Well, that leaves us with b to the 4th. Dividing both sides by 16, we get b to the 4th equals 16. We have to think for a moment, what to the 4th power would equal 16, and the answer is 2. We're going to plug that back into that equation, so there I have rewrote it. Plug in the 2 for the b, and that's 4, and we divide by 4. We solve for our a, and now here we're going to substitute it into this equation where we've got our a is 4, and our b is 2, and that's the answer to what would be the equation of the exponential function that has these 2 points. So we're going to do it once more in B93 using these 2 points. Plug them in, write your 2 equations, solve both equations for A, set the 2 equations equal to each other. Now you got to be a little tricky here, thinking that when I solved for A I would have divided by b to the negative 1, but to divide by b to the negative 1 is multiplying by b to the positive 1, because it's like that reciprocal idea. And so we've got this problem. We're going to multiply both sides by b cubed because we just want to get rid of this denominator here. And when we do that, we have negative 2b to the 4th equals negative 162. Dividing both sides, we get b to the 4th equals 81. What to the 4th power is 81? Well, that would be 3. So I'm going to plug that back into our first equation that I got over here. I'm plugging that in, the b. I have b to the, b is 3, so I've got 3 to the negative 1. Well, remember that 3 to the negative 1 means 1/3. So to solve for a, I need to get rid of this 1/3, so I'm going to multiply both sides by 3. And negative 6 is what a is. I need to now replace it into the equation, so my b is 3, my a is negative 6, and there's the equation.